Welcome to Lesson 13, Finding Distances in the Coordinate Plane. This lesson does come after lesson 11. We did skip 13 due to timing. So today we're going to start by looking at the distance in coordinate planes between 2 points. So let's get started with the warm-up. Which one has the closest distance? What I'm going to have you do is set the timer. I'll give you 3 minutes, not 2. Work on your own, and then compare as a group or as a team your answers. You have 5 different pairs of points. We can imagine these points all being on a coordinate plane. Figure out how close or how far apart they are from each other. Now that you're done, let's check with my answers and see how well you did. So with A, what we noticed, hopefully you noticed, is that they both have the x value of 2, which means that if you go over 2, you can go up 4 to 2, 4, and you can go over 2 and up 10 to 2, 10. So you can see that this has a distance or a delta of 6 units. We can imagine that line on a graph and we can see those 6 units. The second one, we can see that they both have the y value of 6. So we can say, okay, they're up here on 6 and we are going -3 up 6 and over 5 up 6. So from -3 to 0, that's 3. And from 0 to 5 is 5. So this has a delta of 8 units. The next one has the same x, which means that it would be -12 on the x. We'd come way back here to -12. And then we're going down -12, -12, 12. And then we're going back -12 and down 1. So we can see from 1 to 12, that distance, even though it is -1 to -12, that distance is 11. There's a delta of 11. For D, they both are sitting on the x at 7. So they went over 7. We have 7, 0, and we have 7, -9. So that line has a delta or a distance of 9. This last one, we have our -10. So you're going to go, oops, over 1, down 10, 1, down 10, and back 4, down 10. So from -4 to 0 has a distance of 4, and from 0 to 1 is 1 more, so 4 plus 1 makes a distance of 5. So the closest points that we have here were E, right? So we can see E, and then A, B, D, and C. Name another pair of coordinates that would be closer together than the first pair. So the closest was E, which is right here, distance of 5. Well, we could just go ahead and make a graph, and maybe I'm just going to do a distance of 1 sitting on the x. So I could say, well, -1, -1, and oh, not negative 1, negative 1. Negative 1, 0. Negative 1, 0. I'm going to go back 1, and then I'm going to go 0, 0. That would have a distance of 1. And again, what you're probably beginning to notice, right, is that when you have the same value for an x or for the y, you're going to find the difference between that second coordinate. Now they want you to do another coordinate that would be further apart from the last pair. So that last pair was C, and C was a difference of 11. So again, we could come here and we could say, well, I'm going to go with something larger than 11. So maybe I'm going to go back 10 up 2. Okay. And I'm going to go, that's a distance of 10. And let me go another 10. So now I'm sitting at positive 10 up 2. So we have a difference of 10 and a difference of 10. So a total difference of 20. And again, the 2's, that y value is setting them to be in a line with each other. So we're going to use this to begin to look at how far apart different points are on a coordinate graph. So find the distance between the 3 points shown. At this point, if we're looking at how far apart, two minutes. Maybe I'll give you, let's set a timer for 5 minutes. After you've all worked it out and you have found the distance between these 3 points, we'll come back together. Okay, so you've had your time, and hopefully what you saw was that because these 2 points share the y or the x value at negative 14, we can see it's going to have a line, while this leg shares negative 3 for the y. And again, this one is sharing negative 14 for the x. What we can notice is that that third point or that third line connecting them is this line here. And that line is on a diagonal, and that diagonal is so interesting because it has just created for us a right triangle, and we're able to use that Pythagorean theorem. And then we're able to use this idea that if I know 9, up 9 and down 3, we have a distance of 9 and 3 more, which is a distance of 12. And again, we can see 9 minus the negative 3. That's going to give me my 12 units. The other leg goes from negative 14. It hits 0. So that's a difference of 14. And then 14 to 16 is a difference of 16. So this bottom leg has a distance or a delta of 30. Now 30 units. Now what's nice about this is in order to find the hypotenuse or the distance, we're going to go ahead and use the Pythagorean theorem. And we have our 12 squared plus our 30 squared is going to give us c squared. 144 plus 900 equals c squared. We're going to add those together. So this distance is the square root of 1044. Moving on, perimeters with Pythagoras. So we're going to look at the Pythagorean theorem here. which figure do you think has the larger perimeter? So hopefully the first thing you're noticing here is that J and K, these triangles, are not like the triangles we've been using. They are not right triangles. Because they're not right triangles, we have to put a little more effort into solving to find those distance. Now, the nice thing with this is that the distance between these triangles could be thought of as different right triangles creating these three different hypotenuse. So, first I want you to select a triangle that you think has the larger perimeter. Once you've done that, you're going to fill in your thought here. Then you're going to work with a partner. One of you will choose J and one of you will choose K to find what those distance are going to be. As you work with this, let's begin to think about how would this look? If I wanted to connect these two lines, I could create a right triangle, which would then give me that distance, and let me change this, of this red line here. So because again, I know I'm going -2, this is -2, -2, and I need to bring this all the way up so that it is going to go -2 to a +2. That gives me this missing point. That +2 then shares the same +2 in that third point. Now I would be able to do that distance. So now that you've seen that example, let's look at the K, and we'll give one example here. If I noticed I went over 9 and up 2, I would have to go up another 2 to get to 4 for this point. And that point is sitting on 7 up 4, this one here. So this one must be 9 up 4. Let's see if that makes sense. Over 9 up 2 got me to this point. Staying at 9 and going up to 4 will help me to make a right triangle right here. So now I can look at this and I would notice that there's a side here of 2, a side here of 2. So I then could find the red length of that line on K because I could use the Pythagorean theorem. So selecting one of these triangles, go ahead and calculate the perimeter for each of these triangles. Then you and your partner will compare your perimeters to see who has the longest perimeter. Okay, now that we're back, let's see how well you guys did with working through these problems. Here we said we had -2. We're going all the way over to 4. So -2 to 0, -2 is 2, and 0 to 4 is 4. So this has a total distance of 6. Here we went from 2 down to -2, so that is a delta of 4. So we can do 4 squared plus 6 squared equals c squared. 16 plus 36 equals c squared. 52 equals c squared. So this side length is c equals the square root of 52. And we know that the square root of 52 is about 18. So I'm going to say 18 here. Then we can look at the other one, and we're going from 4 all the way down to negative 4. So 4 to negative 4 is a distance of 6. And then here I'm going from 2 to 4, so a distance of 2. So for this side, I'm going to do 2 squared plus 6 squared, 4 plus 36, 40. So c equals the square root of 40. Oops, I wrote the wrong number there. We're just going to keep this. Square root of 52. This is the square root of 40. And then this bottom triangle, I'm going down 2. And then I'm going from 2 over to 2. So 4 is that distance. So 2 squared plus 4 squared. 4 plus 16, square root 20 is this side here. So we got square root 40 plus square root 20 plus square root of 52. This is the perimeter of J. K would be this first triangle here, this red one, was 2 squared plus 2 squared equals c squared. 4 plus 4 equals c squared. 8 equals c squared. So the square root of 8 is that side. And in green, we'll go from 2 all the way down. There's not a very pretty line, but that's okay. Oh, there's a typo here, over 8, negative 5. So there's negative 5. So 2 to negative 5, that is a delta of 7. And then we're going 7 to 8, that is 1. So 1 squared plus 7 squared, 1 plus 49, square root 50. So square root 50 is this side. So we have the square root of 50 plus the square root of 8, plus we have one more side to do, and this is a very narrow triangle as well. So this is going from 4 down to negative 5, so we have a delta of 9, and again a delta of 1. So 9 squared plus 1 squared, 81 plus 1, 82, so square root 82 is that side. So square root 82. K is approximately 19 units in the perimeter, and the triangle J is approximately 18 when we do all the work. So we can see K is a little larger. The most important thing to take away from activity 2 is that when you see diagonal lines on a grid, you can create those right triangles that will surround the non-right triangle in order to find the length of the hypotenuse. Okay, we're going to skip the Are You Ready for More? And I would like you to look at activity 3, finding the right distance. So have you work in your tables, and each person in our group is going to select one of these. So you're going to select either A, B, C, or D. each person in that group is going to figure out and find the distance between the 2 points. Then you're going to share it out in your small group, or you could share it out with the whole class. So let's look at A. If we have -2, 1, and 6, -5, how would that look? Well, if you did your coordinate plane, or grab some graph paper from the back of the room, that's going to help you to really figure this out. You're going to go over 1, down 2. Oh my goodness, I'm backwards. Back 2, up 1. And the next one is 1, 2, 3, 4, 5, 6 to the right, down 5. As you can see, you have your triangle hypotenuse. You have a diagonal. You cannot find that distance unless you were to create a triangle that's going to incorporate that diagonal. So we can see here, I went back 2, I went up 1, and then this bottom point right here is down 5. So 1, from 1 to -5 is a delta of 6. And then this other leg starts at -2 and goes all the way over to 6. That is going to be a delta of 8. So we've got to figure out what is that diagonal. 6 squared plus 8 squared equals c squared. 36 plus 64 is c squared. 100 equals c squared. So c equals 10 units. This can be done with all of the different points that you have. All of the distance, no matter the points, these all have a distance of 10. We could look at one more together, and then you will have time to take your quiz. Because this is the last quiz of the year, I'm going to let you guys have your books opened if you feel that your notes could help you. So let's take a look at D. D is -2, back 2, and down 5. -2, down 5. The second point is over 2, 3, 4, 5, 6 to the right, and up 1. So using graph paper, again, I can draw that diagonal. That diagonal can be turned into a right angle. We can use the points and the coordinates on the graph to help us. We went up 1, and then over here, right? So we have moved up on y, down 5, total distance 6. This bottom leg starts at -2 and goes all the way over to 6, which is a delta of 8. And then we go right into the exact same equation as we did down here. Okay, so what we were able to do today is use the Pythagorean theorem to find the distance between any 2 points on a graph. When we have those, we can talk about finding the difference between those x's. And again, the x is going from -2 back to 8. So that would be a change of 6. We can see a change in the y. We start at 4 and we go down to -3. So we have a change of 7. Once we see those changes, we're going to take the 7 squared and the 6 squared, and we can find the hypotenuse. And they give you an example down here as well. Take some time, read over this example, as it does help you to explain the lesson that we just did. Once you're done, you have your last homework problem, the last homework, I should say, for the school year, lesson 13. This is due on Monday. Have a great weekend.